So today we are going to look at the flow of the cerebrospinal fluid. Flow of cerebrospinal fluid. So a question may come in surgery or in medicine where you'll be asked to say with a head of a well-labeled diagram, describe the flow of CSF, cerebrospinal fluid. So what you need to know is that the brain has 4 ventricles. The brain has 4 ventricles. So these ventricles, they are chambers, just like the way the heart has chambers, even the brain has what? Chambers, which we call ventricles. There are 4 in total. So we have two lateral ventricles, 1/3 ventricle, and the 4th ventricle. The 4th ventricle. So these ventricles, they are filled with a very delicate fluid, which is the cerebrospinal fluid. So the function of this fluid is one. So the functions of this fluid is one, it protects the brain. So in other terms, we'll say it acts like a shock absorber. Then, so you'll be able to see how this cerebrospinal fluid is able to do this. Then number 2, it also nourishes the brain. So it contains some nutrients. Then the other thing is that it also plays a role in immune system. So you're going to find the white blood cells in this delicate fluid. So when you are asked to draw with the aid of a well-labeled diagram, draw and explain the flow of cerebrospinal fluid, what you need to know is that the brain is protected by what we call the meninges. It's protected by what we call the meninges. So these meninges, the meninges of the brain has 3 layers. So it has what? How many layers? It has 3 layers. So the outermost layer, which is this one, the outermost layer is what we call the dura mater. The dura mater. Then the middle layer, which is this one, this is what we call the arachnoid mater. Then the innermost layer of these meninges is what we call the pia mater. So in between the dura mater and the arachnoid is a space. This space that you are able to see here, this space, and we call it the subdura space. So this is the dura mater. This is the arachnoid. Then the inner one is what we call the pia. So we've said this space between the dura mater and the arachnoid is what we call the subdura space. Yes. So the space in between the arachnoid and the pia mater is what we call the subarachnoid space. Subarachnoid space. And this is where you are going to find the cerebrospinal fluid. This is where cerebrospinal fluid flows through. So this is where you're going to find the cerebrospinal fluid flowing. So where is this cerebrospinal fluid produced? So before we talk about where it is produced, first of all, I'm going to show you the 4 ventricles that we've already listed here. So these are the lateral ventricles. So this is the left lateral ventricle, and this is the right lateral ventricle. So remember the anatomic structure. Whatever is facing you, yeah, that's the opposite of it. So this is the left, this is the right lateral ventricles. So these are the lateral ventricles. Then there is this is the third ventricle. Then this here is the fourth ventricle. So where is this cerebrospinal fluid produced? So in each of these ventricles, we have specialized cells that we call choroid plexus. So in each of these ventricles, there are specialized cells that produce cerebrospinal fluid, and we call these as what? The choroid plexus. So they produce cerebrospinal fluid in each of these ventricles. So approximately this choroid plexus produce about 500 mils of. So in a day, about 500 mils of CSF is produced. So we don't need to have excess production of CSF, because it can be an issue, it can bring about problems. So this fluid, it flows through these ventricles down. This is the spinal cord. It flows through these delicate ventricles and finds its way into the subarachnoid space until this structure here is what we call the subarachnoid villi. Yes. So we need to regulate the production and flow of this CSF. Why? Because if there is excess production of CSF and disturbed absorption, it is going to lead to a condition we call hydrocephalus, where there is excess buildup of CSF in the cranial cavity. Yes. So we've said this cerebrospinal fluid is produced by specialized cells found in each of these ventricles, which we are calling the choroid plexus. So after this cerebrospinal fluid is produced in the lateral ventricles, it has to flow through this duct here. So it has to flow through this duct here into the third ventricle. So what is the name of this duct here? So the name of this duct here is what we call interventricular foramen. Interventricular foramen. The other name is foramen of Monro. The other name is foramen of what? Monro. So once cerebrospinal fluid has been produced in the choroid plexus found in the 2 lateral ventricles, it flows to the third ventricle through the interventricular foramen or foramen of Monro. So it has now reached where? So this fluid is being produced here. So when you are drawing, you have even to show the arrows. When you have to draw, You have to show the arrows. So it has reached here in the third ventricle. So again, in the third ventricle, it is going to flow. It is going to flow into the fourth ventricle through this other duct here, through this duct, which we call the cerebral aqueduct, or aqueduct of Sylvius, So it is going to flow from the third ventricle to the fourth ventricle through this duct, which we call the cerebral aqueduct or aqueduct of Sylvius. From here, it is going to continue. It is just going to continue from the fourth ventricle through these two ducts here, through these ducts. So what do we call these two ducts? So these ducts, the ducts which are found on the lateral sides, we call them, they are foramen of Ruska. So L for lateral, foramen of Ruska, they are found on the lateral side. Then the ones on the middle ear, the ones on the middle part here, we call them foramen of Magendie. M for middle, foramen of Magendie. So this fluid is now out of the fourth ventricle into where? Into the subarachnoid space here. So into the subarachnoid space, this is where the other ones will go down the spinal cord like this, protecting the spinal cord and nourishing the spinal cord. The other one will just continue circulating like this, just like that. But remember, we said this fluid that is being produced needs to be regulated. So the body has this way of regulating the amount of fluid that is in this cranial cavity, where so it absorbs this fluid, cerebrospinal fluid, through these structures, the subarachnoid villi, into the subarachnoid villi. So they will now be absorbed by the subarachnoid villi into what we call, there's a sinus which will drain now into the venous return. So from the subarachnoid villi, this fluid is now going to find its way in the into the venous return. So this is how the cerebrospinal fluid flows. So let me just do a quick recap, then we will end it from here. So where is this cerebrospinal fluid produced from? So it is produced in the specialized cells in each of these four ventricles, which is the choroid plexus. Then it flows from the lateral ventricles into the third ventricle through the intraventricular foramen or foramen of Monro. Then from the third ventricle to the fourth ventricle, it flows through the cerebral aqueduct or aqueduct of Sylvius. Then it flows from the fourth ventricle through two foramen, the foramen of Ruska and foramen of Magendie. So this is the brain tissue here. Which is being protected. So remember, outside here, there's the skull. So imagine if someone shakes your head or they punch you to the head. So that's going to produce some tension. So remember, because of this fluid that is here, this brain structure, this brain tissue here is unable to hit itself against the skull because of this delicate fluid that is here. So this is the production and flow of CSF.